so that your variables are lined up. Do you see how this is set up for you? How your x's and then your y's and then your equal sign and then your constant? A lot of our application problems come ready in this format. So if you know elimination, you can skip over substitution that way. So it's called elimination because we want to identify which variable is easiest to eliminate, get rid of. In this set of equations, do you see how the x's are going to be eliminated as soon as you add them together? So your brain, once you're focused on elimination, should be like, oh, look, my x's subtract and they immediately go away. You've eliminated x. Eliminated x. What do I have left? If I add them together, I now have 7y equals negative 14. Do you see how easy that was to solve for y? Like literally one step, and we know that y is negative 2. Right? Divide by 7 on both sides. Y is negative 2. Now this was set up ready for elimination. So they're not all going to be that easy, but if your brain can recognize when to use elimination and when to use substitution, like if you tried to do substitution, I guess you would have had to solve for this x, because you could divide things by 2 and get x by itself. Then you still would have had to plug it into the top equation. It takes a lot longer. Right. So that was a lot easier just because of the way it was set up. So the only thing that's a little bit harder is we don't have like a rectangle part to plug it back into. So you're going to have to do a little bit more work to solve for the other variable. So if I use this top equation, I'm going to have to plug in negative 2 for y. So 2x plus 3 times negative 2 equals negative 4. So I'm plugging negative 2 in for y. Now I have to actually solve for x. It might take you another step at this point. So I have 2x minus 6 equals negative 4. What would I do next to solve for x? Add 6. My other class is still asking me, how do I know when to add? When do I know when to divide? If you're subtracting 6, the opposite is to add 6. So at that step, I'm adding 6, but this time I'm multiplying by 2. So the opposite is to divide by 2 to get rid of it, right? So x equals how much? Anything divided by itself is 1. So my solution is 1 comma negative 2. So on the quiz tomorrow, I might throw one at you that's more geared towards substitution, but maybe the application problem is geared towards elimination. I'm not going to require you to know you have to use elimination or you have to use substitution. The more tools in your toolbox, the better. Okay, so number 2 is a little bit more challenging. It's already set up for elimination, x over x, y over y, constant over constant. But do you see how nothing's going to eliminate right now? I'm going to get all my x's and all my y's back again. So you need to multiply one of your equations by a constant. So that is what you might need to do at step 2. I'm going to multiply the top equation by negative 4. Can anyone figure out why I would multiply this top equation by negative 4? It'll cancel out my x's. So you got to either pick x's or y's. So now I'm going to have negative 4x minus 4y equals negative 16 for the top equation. And I'm going to keep my bottom equation the same. 4x plus 6y equals 10. So that's not that hard of a step to distribute one number to the equation, because whatever you do to one side, if you do it to the other side, you're maintaining equality, right? So now I'm going to do elimination, because do you see how my x's eliminate at that step? Negative 4 and positive 4 adds up to 0. So I get positive 2y equals negative 6. So I'm adding these terms together and I'm adding these terms together. So y has to be negative 3. and see if you can plug it back in. Now you can plug it back into any of the equations, but to me this smaller equation, x plus y equals 4, is probably the easiest. So x minus 3 has to equal 4 if I use the top equation. So what does x have to be? 7, right? Add 3 to both sides. 7 comma negative 3. So the second step, when you have to plug it back into the equation, that's the same as if you were doing the first step from substitution. All right, so this one was already set up, ready to go. This one we had to multiply one of the equations through by a constant. Guess what? You might need to multiply both equations through by a constant. It's still not that hard. I would still use elimination, because if you wanted to get x by itself, you're going to end up with 2.5. If you want to get x or y by itself, you're going to end up with a fraction. So I would rather do elimination. You could either get rid of x or get rid of y, but if this is already a positive and this is already a negative, I would try to get rid of the y's. What should I multiply them by? So yep, if you're going to do 3 and 2, you're trying to get rid of the x's, right? But you would have to do a negative 3 and a positive 2, so that one comes out as negative 6x, one comes out as positive 6x. If it were me, I would do 2 on top and 5 on the bottom. So I get positive 10y and negative 10y. Then I don't have to multiply by a negative number because I already have one that's positive and one that's negative. We're all going to get to the same place. It doesn't matter what you multiply by or which variable you eliminate. So my two equations are going to be 4x plus 10y equals 40. Make sure you distribute to all three terms. And then 15x minus 10y equals negative 40. We did get rid of two things. We got rid of our y's, and that we have 19x equals 0, which is okay. What would x have to be? If 19x's is 0, when I divide by 19, guess what? X is 0. X can be 0. 0 is a real number. It's allowed to be part of the solution. It's not no solution. So 0 is actually a solution. Right, we didn't eliminate all the variables, right? All right, so plug 0 back in to one of the equations and figure out what y would have to be. Yep, so we're going to have to line them up ourselves. So I'm just showing you the three different ways you might see an elimination problem. So 2 times 0 plus 5y equals 20. Good, Owen. So now you're going to figure out what y would have to be, because 2 times 0 is still 0 right there. So 5 times what is 20? Divide by 5. Y has to be 4. So 0, 4 is the solution to that problem. So this was an example where they came all lined up. You just had to multiply to get something to eliminate, and it's okay to multiply both equations by a different number. Okay, so the last one, to me, this is still not really set up for substitution. You don't have one variable by itself. You could work to get this y by itself and do substitution, or you could just add the y to the other side, and then you would have elimination. So I'm just going to rewrite that I've got 2x plus y equals negative 4. So I've changed the top equation, and I've added y to move it to the left side. So now I'm set up for elimination. So you need to be able to manipulate your equation one way or the other. What should I multiply the bottom equation by? You've got two choices. Get rid of the x's or get rid of the y's. Great. What would you multiply by then? If I have negative 3y, I want to multiply by 3 to get positive 3y. Your other choice, you could multiply by 2 and get rid of the x's. All right, so my new equation, I'm going to keep negative 4x minus 3y equals 10 on top. 3 times 2x is 6x. 3 times y is 3y. And 3 times negative 4 is negative 12. So see if you can finish doing the elimination and solving for x and y. Anyone like this method better? You don't? You do? Do or don't, Owen? Do? So, I mean, yeah. We've also not done this method as many times, so it may seem confusing. It's just nice to have more than one method. Some people learn different ways. Some people can see the easier method. Tomorrow on the quiz, you can use either method. You might be making your life a lot harder with fractions or something, but if you stay organized, you should be able to get. So I'm at 2x equals negative 2. So what would x have to be? Yep. See if you can plug it back into any of the top equations and get your final answer for x and y. This equation looks easiest to me. 2 times negative 1 plus y equals negative 4. So if I add 2 to both sides, y has to be negative 2. Gotta be careful with your negatives, but you can choose any equation that you want. It's on number 4. Okay, so 5 and 6, I would like you to take a couple minutes and try them by yourself. They are going to be either the no solution or many solution outcome. You've got one of each. So see if you can do elimination and figure out which one's going to be no solutions and which one's going to be many solutions. Then if you want to try setting up number 7, that's going to be the bonus on tomorrow's quiz. And I'll give you like 5 minutes to try these 3 problems. If you're ready to move on to the guided practice, this is really good practice for tomorrow's quiz. So that's what we're working on finishing after this. 5, most of you should have finished number 5. Did you multiply the bottom equation by 2, I hope? So 2x plus 10y equals 24, negative 2x minus 10y equals 40. Gone, gone. 0 equals 64, question mark, right? Is that what you got? No solution. I would recommend the y's because they're a little bit smaller in number. I would multiply to get to 12 personally. Like if you multiply this one times positive 3 and this one times negative 2, you'll get positive 12 and negative 12. Oh yeah, 6 and negative 4 would work. There's a lot of combos. You got to get rid of either x or y. So if you try my strategy, that'll be one way to do it. But you could also, you could target your x's. Who doesn't know how to do it? But can you do it from this step? If I tell you multiply this by 3, multiply this by negative 2, then can you see what to do next? 18x plus 12y equals 36. Negative 18x minus 12y equals negative 36. That should look awfully fishy. Yeah, if we get 0, I was targeting the y's, right? But I ended up targeting everything. If 0 equals 0, it's infinitely many solutions. You'd get the same thing doing substitution, but you'd have to you'd have to have a fraction here because you can't get x or y by itself. 4 and 6 aren't divisible by each other. So you'd end up playing with substitution with a fraction, which sounds bad. All right, I would like you to try to set up the application problem yourself if you haven't yet, because this will be a bonus, and then it should be set up to do elimination, but I can do it in a minute if you need help, and if you've already done 7, move on to the next page. So our goal is to do this guided practice. It's just 6 questions as kind of quiz review. It says use substitution or elimination. So if you do not like elimination, you do not have to do it. I just think having more options is better, personally. So I'll give you another minute or two to try setting this one up. Maybe you want to look back at yesterday. So we identify that X is our $1 bills and Y is our $5 bills. We have a total of 14 items, and 1x plus 5y equals 34. So now I think it's set up perfectly for elimination. Multiply one of the equations through by -1, and you've got it, right?
Number 4 on the guide practice.
Is it? I don't know. 4y equals, is this 20? So y has to be 5. So now we figure out what that means in this application problem. We have 5 $5 bills. We have 14 bills total, so we must have 9 $1 bills. And then 5 times 5 is 25, plus $9 comes out to $34, right? So you can double check that you did it right. So you're going to take kind of the rest of the time and see if you can do 1 through 6 on this.